Welcome to IDERA Virtual Education. In this video, we're going to be taking a deep dive into the SQL Safe Backup and Recovery tool for Microsoft SQL Server. IDERA has been working on this product for quite a few years now. It's probably 12 to 13 years old, and we average around 2 to 3 releases a year. So it's a very mature product built from the ground up for enterprise backup and recovery of Microsoft SQL Server. And when we talk about this tool, obviously a lot of people are really interested in backup, compression, encryption facilities, but I think a lot of what drives new users and existing users to continue on with this tool is frankly some of the more advanced restore features. So I think in the beginning of the demonstration, we'll talk about setup, getting servers added, different options around the backup services themselves. We'll then move into the basics. So how do I do a backup? How do I schedule backups? And then when we start talking about restore, there's a lot more options that I think this tool offers than the other third-party products out there in the marketplace, including what native SQL Server has the ability to do. So we're going to cover quite a few of the more advanced options around recovery. Now, this tool does support a wide variety of different SQL servers. Everything from SQL 7 all the way up to 2017 are supported. And the backup target facilities are also pretty diverse. What I mean by backup target is, where are we actually going to write these backup files to? I think most of our customers are used to, native, where you can back up to a local drive or maybe even a network share, which we can obviously do. Any UNC path, any local drive would be supported, but we also support, Amazon storage. We have Azure storage. We can write directly to Tivoli tape systems. We also can write directly to data domain. So there's a lot of different options that we offer as far as where you want to store these backup files. On the restore side of things, obviously we can do a restore and we can do point-in-time restores, assuming that you're doing transaction log backups as well. But there are some really interesting features such as instant restore that we'll cover. Instant restore is basically a prioritized restore that gets large databases up and available very, very quickly. So you don't have to wait for the entire database to be restored before you can start working with it. So these instant restore databases have full functionality as restores are taking place, so a prioritized or an online restore functionality. We're also going to cover object level recovery, and it is what it sounds like, right? So there may be certain objects within these databases that we need to restore and not actually have to go through the entire database. So if you have a 3 terabyte database that needs to be restored, you need to pull a table back that's 200 megs. It's really painful to restore all that data just to get to that 200 megs. And with our tool, you can select individual stored procedures, tables, views, just about any object within the SQL Server DB that you need back, you can restore individually. And then we'll also cover a feature called Virtual Database that is similar to Instant Restore. It's also somewhat similar to object level recovery because people will use it often in an OLR situation. But the idea of virtual database is not actually restoring anything. What we basically do is trick that SQL Server instance into believing that this backup file or set of backup files is an actual database. And then, once we kind of trick that SQL Server into believing, this is real, you can really do anything you want with these virtual databases. But at the same time, because we didn't restore anything, all the size and space required for that data is still in the backup, it really gives you some big advantages so that you don't have to go find that extra drive space to restore to, nor do you have to take the time, right? So we're just attaching those files. So there's a lot that this tool has the ability to do. It's very beneficial for large enterprise, and I think we'll start first with architecture. So the architecture of this product is maybe a little bit different than some of the tools that you're used to at IDERA. And I say that because there is an agent. So each one of the SQL Server boxes, each one of the servers that's hosting SQL, I should say, will have the SQL Safe Backup service deployed to it. The SQL Safe Backup service is really the mechanism within the tool that does the backup and recovery operations for us. So, when we're compressing, for example, the actual backup service is the piece that's doing the compression. When we're restoring, it's doing the decompression. So each server that you're going to back up will have that agent deployed to it. Now, From a licensing standpoint, we don't license agents. So this tool is licensed by instance of SQL backed up. So you can deploy that agent out to any number of SQL Server within your environment, and you can restore to them all day long. We never check for licensing around restore. So that's something to keep in mind. We only license this tool for backup. Uh, so once that agent has been deployed out to that server, the agent's really going to be communicating back to the SQL Safe application through the SQL Safe Management Service. So the SQL Safe Management Service is a central broker of communication that normally resides on a secondary SQL box or secondary server centralized within your enterprise. So you can think of it again as kind of a broker of communication. So if I'm sitting on my workstation, I have the desktop client open and I say, let's go back up production 1. What's going to happen is a message will go from that management service to the agent out on production 1 and start telling it to do work. As the agent, by the way, is doing its work, it's going to respond back to that management service with updates basically of where it is, right? So I'm 33% done with the backup. This is how much data I've compressed already, right? So that messaging is going to come back to the management service, and it will cache that data and store it in our repository, as well as display to the end users who may be working with the application. There is a repository, as I mentioned, there's a repository that really stores the metadata around backup and recovery history. So, when did the backups take place? How long did they last? Where are the backup files located? That kind of thing is all stored in a centralized repository. And that gives you a lot of benefits, especially on the restore side of things. If I need to do a point in time restore and I have, 30 log files, a differential, and a full, I don't have to go find all those files, figure out where they were located, when they took place. The tool already knows that stuff, so it'll build out a timeline view for you, and you can pick and choose, kind of basically point and click within the timeline, and that timeline view is going to, give you a really quick and easy way to find that exact point where you're going to be. Now, if you lose the repository for some reason, that's okay. We can still manually go point to backup files, and we can actually, grab a handful of files, and it will build a timeline based on the metadata built into the backup file. So you're not going to lose functionality if the repository goes away, but it is a really nice to have piece of the product because it does simplify a lot of the operations. And then finally, the UI. So as an end user, how am I going to interact with this product? We offer a couple different options. There's a desktop client, which is more maybe traditional, I guess. It's been in the marketplace for a little bit longer. Frankly, it's what I generally use, and I recommend new users to kind of start with, just to kind of get things set up and configured. We also offer web consoles, and the web consoles are fantastic. One of the nice benefits of a web console is you don't have to install any software locally. You can just go hit a URL. And there are some more advanced features, for example, OLR and virtual database that are available within the web interface that haven't yet been introduced into the FAT client. So we'll cover both of them. And then I should also point out reporting. So there is a report pack that comes included with SQL Safe for SSRS. So if you need reporting around backup and recovery, which most people do, you can build some really easy SSRS subscriptions around this RDL pack that's reading from our repository. I'll also point out when we get into the web client that there's a lot of export functionality in that web client so that you can build PDFs and Excel spreadsheets, XML files around backup and restore history as well. So the architecture really isn't that complicated, but let me kind of show you what this architecture looks like in the real world. So if we back out of PowerPoint, we actually start taking a look at the application. This is the desktop client. It's really very simple. As you can see down the left-hand side, we have navigation. At the bottom, we have different core areas. Policies, for example, we'll talk about a little bit later on. That's where we build our scheduling. Agents. So the agents themselves, right? So every single SQL Server that you need to back up or restore to will have an agent deployed to it. This agent view that we're looking at now is talking about, first off, what servers do we have agents deployed to, what versions, which management service is that agent responding to, what the priority is as far as, is it running above or below normal priority on the server? So maybe we want to give it a lower priority than the other services or applications that may be running. So there's different ways we can kind of manipulate and play with how those agents are going to respond. And to deploy the agents, I think obviously that's one of the first things that you're going to do, right? You install the product, then you start adding servers. Once you've added a server, it will deploy the agent. So before you start adding servers, one of the very first things that you're going to want to do is go to the Tools menu, go to Management Console Preferences, Agent Deployment. Agent deployment is really talking about what account is ultimately going to run the SQL Safe service. So when I deploy that out to this remote SQL server, I want that already predefined so I don't have to manually put that in. Now there could be exceptions, right? So you may want, it may not be the SQL Safe account on every single server, but if it's the majority of, going to be the account on the majority of the servers, I probably want to input that into the solution before I do my agent deployment. It just simplifies things. So if you're brand new to the product, this is probably the first thing I'm going to do is I'm going to put in the account that I want those agents to run as. Once I've done that, it's pretty simple. You can go over and say register SQL Server. It will do a scan across the environment, try to find what it can. This is not a very sophisticated scanner. It's primarily looking at native ports and browser service and that sort of thing. So I can't guarantee it's going to find everything, but generally it will find a good number of your SQL servers. If it doesn't find something, right, you can always type it in. You can use a semicolon, so demo2. So as many SQL servers as you need to, you can put them in as a string. If you find one, so demo2, maybe I want to add node 1 in here as well. So it's pretty simple. So once you've added your SQL servers, they'll show up in the list, and then you can right click and say install SQL Safe Backup Agent. Now, I've already done that. That's why it's grayed out. Nevertheless, maybe we went through an update. So if I already had the agent deployed out there, and I updated the main application, it would say update SQL Safe Backup Agent. You'll also see here that when you do the deployment, you have the option to install extended store procedures, the SQL Safe extended store procedures. That is optional. There is a feature, to be exact, it's the T-SQL scripting option for this tool that would leverage the extended store procedures, but it's not something that the application itself is going to leverage. That would be something that you do outside of the core application. So it is optional, and if you decide, initially not to deploy those store procedures, you can always come back, like, as you can see here, you can come back later and deploy them if it's something that's required. So getting the servers added, really not terribly difficult. Once they've been added, you can start doing ad hoc backups, which I think we'll start with. Ad hoc backups are pretty simple. We'll look at perfmon. All right, so this is a pretty simple database. It's actually the native performance data warehouse within SQL Server. Right now, mine looks like it's roughly 12 gigs. It's probably closer to 10, so there's probably some free space in there, but I think this will be a good sample database for us. So we're going to go ahead and do a backup of it. If you notice up here at the top, though, there are some wildcards. So I could say, let's do all user, all system. I could do every database. And then, as I'm going to do, I'm just going to select one of them. So you have some options here. Maybe we made a mistake and we picked the wrong server, so you could change there. Also, maybe it wasn't in the list in the first place. Let's go ahead and register one on the fly. So you can do some of that stuff if you need to. And then ultimately, it's going to want to know, what kind of backup do you want to do? Now, this database is in simple recovery, so there's not a log backup option because, frankly, you don't do log backups of databases in simple recovery. But I do have the option to do file backup, so I can go pick individual file groups, differential backups, assuming that we've already done a full, and then you can also do your basic full backup. Now, there are scenarios and even things that we're doing in SQL Safe that could require LSN orders to stay intact, and there's always the copy only option for backup, and this would be highly recommended obviously if you're doing something like log shipping or always on availability group backups of primaries. There's certain things that you may want to leverage a copy only backup for. Copy only backups can be restored, but the idea here is that if you're doing maybe more sophisticated backups, again, like always on or log shipping, something like that, and you want to do something outside of that traditional backup policy that you have in place, go ahead and do a copy only. You can also verify, and what we mean by verify is as soon as the backup is finished writing, then we will go back through that backup file looking at checksums and verify basically that we can actually do a restore with this file. Now, this is not a CheckDB. This is doing a verification against the integrity of our backup that was created, but it is beneficial, very beneficial in letting you know that, hey, we do have a restorable backup file available. And I'll go ahead and leave that selected. Naming and describing optional. There's not really a requirement to put that in here, and a lot of the metadata that we're going to create automatically around this backup file is already kind of predefined. So I generally don't put one in, but there could be a good reason to do that. It's kind of up to you. So once we've identified what we're going to back up, what kind of backup, then we start looking at targets. I mentioned earlier that there's a lot of different options we have for targets. So single file backup actually could be, I guess, two different types of targets. So I put in a UNC path. That's generally what I do. But if you hit the ellipses, it's going to browse the file system of the SQL Server that you're backing up. So if you're on your laptop and you say, browse, it's looking at the actual remote SQL Server's file system that, trying to understand where you want to write that to. In my case, I generally back up to a UNC path, so whack, server name whack, and then wherever you want it to go. We do have naming conventions and variables around that naming convention pre-built into the solution. That was something that you could modify in that Management Console preference feature. So maybe you want it to be, instance and then slash, so it would create a new directory for the instance name. Then the backup file would be database, backup type, timestamp, right? So you can do or you do have quite a bit of control, I should say, around the backup file naming convention. And you also, if you're using the single file option, can mirror. And one of the benefits of mirroring, in this case, we'll mirror to the E drive. One of the benefits of mirroring is that you can have multiple backup files created simultaneously. One goes to Chicago, one goes to New York. One stays local, one goes to a network share. And frankly, you can go up to 3. So you can have multiple files written simultaneously if that's the direction you need to go. Append and overwrite really don't necessarily come into play, at least by default they don't, because we have a timestamp within the backup file name. So pretty much every file will be unique. But if you did modify the naming convention to not have a timestamp in it, append and overwrite would come into play. And the other really big benefit, which is relatively unique to IDERA SQL Safe, is network resiliency. And what we mean by network resiliency is if there's some sort of network hiccup during the backup process. So let's say we have a 2 terabyte database, we've been backing it up for 4 hours, it's 98% finished. The last thing I want to do is kill the backup because your network goes down for 5 seconds or 2 seconds or 1 second. So our network resiliency portion of the tool is really here to pause the backup when a network problem occurs and then pick up where it left off. And that's definable, right? So retry every 10 seconds, fail after 300 seconds of continuous downtime, and then cumulatively across the entire backup process, if we waited more than an hour, we'll kill it. But you can raise and lower those values to match whatever your parameters may be. Again, the big benefit there is really born out of large databases. So if you're almost done with a big giant backup, the last thing we want to do is start over. So we have those kind of features in here to save you quite a bit of time. It's also great for WAN backup. So if you're backing up over WAN or slow network, huge benefit there. I can't tell you how many times that saved customers. Okay. So target location, single file, pretty straightforward. I only want one file required to do the restore. I might write multiple files to different locations, but only one of them is required to do the restore. I also, though, could do striping. So striping, and I think we can go all the way up to 64 stripes. I'm not going to do that here, but let's say 10 stripes. So if I have giant databases, I might want to break those up into little files, multiply the I/O out across many controllers. You can also go directly to tape, data domain, Amazon S3. There's Azure support as well. That's something we would configure within the web console. But you do have quite a few options as far as, where are we going to write this backup file to? Then we're going to start getting into compression, encryption, and maybe some advanced features like logins. Our compression is pretty unique. There are different philosophies out there as to how we want or what we want to do as far as compression goes. Do we want to compress? You don't have to. And there may be certain circumstances like TDE, transparent data encryption. That's all encrypted data. So when it comes to the SQL Safe Backup service through the VDI, that stuff is coming to that service as an encrypted set of data, and that stuff doesn't compress very well. So we can compress it, but it might not be the compression that you really want based on the file size. So maybe you don't want to expend those CPU cycles to try to compress that. You don't have to. You also will notice in here that there's level 1 through level 4. I consider these kind of old school. These aren't necessarily the compression algorithms that we recommend that our current customers use. We do leave them in the product or we have left them in the product over time because we do have legacy customers who already have things configured that way and they just really don't feel like changing it. But what we recommend is IntelliCompression, and you'll notice that there's 2 different options for IntelliCompress. IntelliCompress optimized for size, IntelliCompress optimized for speed. So the Intella part of IntelliCompression is intelligence, basically. And what that's really talking about is that the backup service is intelligent. The backup service is monitoring every 2 seconds CPU, memory, disk, network. And if it sees that, let's say the CPU is under load, right? The SQL Server is doing its job. There's a bunch of users hitting these databases. There's a lot of SQL load coming through. Well, the agent will recognize that and say, hey, I'm not that important. And it will start backing off the compression to give that back to the SQL Server or whatever application needs it. But at the same time, if it's like 3:30 in the morning and nothing's happening and we have all this idle CPU out there, it's going to see that as well and say, boom, I'm going to take this and I'm going to run with it and I'm going to get some crazy compression ratios. So you have a good balance here, and it's also kind of in the name, talking about what we're really trying to optimize for. Are we trying to get the most compression we can possibly get? That's kind of what the iSize algorithm's all about. The iSpeed is really trying to get this done really quickly. It can be a little misleading in that if I'm backing up over a slow network, then maybe iSize will be a little bit faster because I'm writing less data. Nevertheless, the idea that I try to get across is iSize is really small, iSpeed is really fast. One other thing just to be aware of is it's not a single algorithm, right? So when I start an IntelliCompression backup, there's 20 different algorithms that it can choose from within that iSize or iSpeed set of compression. So if you're trying to back up a really tiny database, where it might only take a second or so to back up, you might not see the biggest benefit because we haven't had time to ratchet up the compression. We're only checking every 2 seconds, right? So this is really, if you're going to do some testing to see which algorithm matches up the best with your environment, we try to recommend that you guys test against similar data as production and similar hardware as production. If I run this on a single core VM with hardly any resources around it, I'm probably not going to get the same benefit or compression benefit, I should say, is what we're going to get off of a nice 32 core production server. So when you do a test in this environment, try to keep it apples to apples. If you only have a kind of scaled down, stripped down box to do testing on, that's fine. But if you're going to be comparing a SQL Safe compression to a native compression, for example, make sure that you kind of do the same backup on the same box. That way we're really looking apples to apples. So I generally use iSize. Space is of value to me, so I try to get these backups done pretty quickly. I also back up over the network, so a smaller file over the network for me actually works a little bit better. Now encryption is also something that we have the option for. The great thing about encryption in the backup process is the data itself will be encrypted at rest. So if someone steals your backup files, they really can't do much with them. They're encrypted. In my case, I always use 256-bit encryption. We don't have really any expense from a resource perspective around encryption. So we call it zero impact. There's not much difference as far as performance if you encrypt versus non-encryption. So really, that's why I go with 256-bit, because I want better encryption, right? So when you do the backup process and you're encrypting, it asks you for a password. So once that password's been entered, that's the password we're going to need to do the restore. One nice thing, though, about the way we use our passwords is we're never going to actually use them in scripts or in jobs or anything like that in plain text. There'll be one hashed value for the password that would be used for backup, and there'll be a completely separate hash value that will be used for restore. So if someone steals your backup scripts that are doing encrypted backups, they can only do encrypted backups. They'll never be able to restore. Ultimately, There's two other little check marks down here that are of importance. Generate maps. You want to leave that on. The idea of generate maps is that it gives us more functionality in the restore process. So if I'm doing OLR, if I'm doing instant restore or virtual database, we leverage the maps that are generated during the backup process and are stored within the actual backup file to make that stuff work, right? So you want to leave that enabled. Unchecking it's not going to really give you any benefit. Keeping it checked gives you more features. You also have the option to include database logins with the backup file. Now, this is optional in that you don't have to necessarily back up the logins. It's also optional on the restore side. So just because you check this box doesn't necessarily mean you can recreate logins on that target server. But you could if you wanted to. So something to keep in mind. And then ultimately, notification. Now this is a backup we're going to watch happen. So I'm not going to really configure notifications. Obviously you have options in here. You can type in any email address you want, actually configure your mail server, where we can send that notification out to. So notifications, pretty simple. And then we'll look at the summary. So what are we about to do? We're about to back up this Perfmon database. Now, we have different ways we could actually do this. Obviously, we're going through a wizard here, so the backup button would kick that off. That being said, as we went through this wizard, all the inputs that we put in are being recorded, and it's generated this nice little command line script that I could leverage to do the backup. So it's calling my exe to backup Perfmon to a UNC path, also mirroring to a secondary path, my network retries. So that's for network fault tolerance, backup type, encrypted password. My password is 123456789. Obviously, that is not it. So it's all hashed out. Nobody's going to steal your passwords from stealing these scripts if you wanted to go that route. So this is a command line script I could leverage to do the backup. I could also do it through T-SQL. But if you remember back, I talked earlier about extended store procedures. So if you did want to do a backup or recovery operation via T-SQL, it's possible, but you would have to have deployed our extended store procedures. So that's something to keep in mind. This is the reason to deploy the extended store procedures. Otherwise, we're really relying on the command line. So all of our scheduling and restores and instant and all that stuff is done through the command line, not through T-SQL, so it's not a requirement to have that out there. And then obviously, another option would be hit the backup button. So when I hit backup, what happened was my desktop client told the management service, hey, let's go do a backup. It went and found the appropriate agent, and now that agent's doing work and responding back to the management service and giving me the input within my view. So if I select that, it's going to give me real-time input, right? So how much data have we compressed, what the total size is, what my compression percentage is. So it finished, right? So I compressed around 10 gigs down to half a gig, less than half a gig, 95% compression, and it took 19 seconds. The verify ran after the fact, so that's a secondary operation. That was another additional 6 seconds, but we had the data backed up within 19. So backup file was valid, and this is actually the processing of the backup file. So I was doing about 471 megabytes a second, which is pretty good for this is just a little laptop that's running a bunch of virtual machines. So that was a really good performance for the type of hardware I'm running on. And this isn't some special database. This is, a typical sort of system-like database that Microsoft would be creating around performance data. So really, really good performance around these backups. And just to give you an idea of what that compression would compare to, if we come, in here, so this is that same database that I backed up. This was actually a while back, so this was a couple months ago. Nevertheless, it hasn't really changed since then, so it's basically the same database. So this is my SQL Safe Backup here. Again, about the same compression, maybe a little bit less compression than what we saw today. Now these are dynamic compression algorithms, so they aren't going to be exactly the same every time. But if you notice up above, that's a 2016 native compressed backup of the same database. So this is about a 10 gig database that Microsoft compressed down to 1.3 gigs versus IDERA's compression, which took that down to less than half a gig. So almost 3 times better compression, meaning that that's a lot of storage space saved as well as time, right? So really nice benefit of the tool is it's fantastic compression facilities. So that's how we do just a traditional backup within the product. And I like to start with that because it helps you understand what all the different options are. It makes it a little bit easier to explain, scheduling and policies and those sorts of things. So when we talk about scheduling, obviously that's how most backups are done with SQL Safe. There are Our schedules are what we call policies. So the idea of a policy is that I'm going to create a style of backup, right? I want full backups to run at midnight. I want differentials every 8 hours, and I want T-logs every 15 minutes. That might be our internal controls around how backup should work. And then I can start adding objects to those policies, right? So the way I actually break my policies down are into uh, it's kind of broken down by recovery model. So I have a policy that does full and differentials. Generally, if we look at this policy, I called it full and differential. By the way, by default, and I think this is preferred, by default, the way we schedule these policies are through SQL agent jobs. So as the policy is created, the actual management service will reach out to these remote SQL servers that the policy applies to and create agent jobs locally that are designed to do the backup or backup in this case for you. The benefit of that is that the backup in itself is running autonomously. It doesn't require a management service, a repository, a console to run. It works on its own, right? So that is the default and the preferred method, I think, for scheduling. But there are environments where you maybe don't have the agent enabled, or like an express instance where you don't have the ability to have an agent in the first place. We can do our scheduling if we need to via the SQL Safe Backup service, and you can monitor as well. Monitoring meaning that maybe you take our T-SQL script and throw it into a maintenance plan. We can just monitor to make sure that that's working as we've defined the schedule to be. So name, set up your options. Then we start talking about targets. I've already done this, but basically I just said add every instance, all user databases. On my Dev2 server down below, this healthcare database is log shipped, so I don't want to do backups with it. It has its own little backup strategy, so I've said exclude. So all the other databases are in here, but I've excluded that one. I should also point out that if I say choose, actually specify databases, there are wildcard options, so you could put in kind of regular expressions in here so that it's finding which ones you really need. And we'll do all user. So all user databases pretty much across the board. And then it will start talking about, all right, well, what are we trying to accomplish in this policy? So it's reaching out, and this right now it's actually talking to all those agents. I guess I hit finish there. All right, so it's talking to all those agents. It found the agents. Now it's happy. So in this particular policy, I'm not going to do logs, so I didn't enable the log option, but I am going to do fulls and differentials. And as you can see, we have different configuration settings for full, different settings for differential. So this is the type of backup that we're doing in compression. The next screen talks about target locations. Also accounts, right? What account do we want to leverage to hit this UNC path? One difference in a policy is retention. How long do we want to keep these backups for? So I keep 5 days worth of full backups, and then down here in my differential settings, I only keep 1 day of differential. So network settings are in here as well. And then this is basically just saying, hey, you're choosing all these remote servers and remote targets. Let's make sure this paths work. We're good to go. And then we talk about scheduling. So I do my full backups at midnight, and I do my differential backups at an 8-hour interval. So again, the idea is that I'm creating a type of schedule, and then I'm applying databases and servers, or servers and databases to that particular schedule. When I hit finish, what it did there was it reached out to any of those servers that maybe I modified, or any objects that were changed, and it reached out and updated those agent jobs for me. So I don't have to ever touch those agent jobs. While I'm talking about it, I might as well show you. So on this server dev1, there's an agent job called SQL Safe Differential Backup for policy full and diff, and there's SQL Safe Full Backup for policy full and diff. So this job does the full differentials every 8 hours. This job does the fulls, fulls every night at midnight. So that's what that policy is doing for me. It is controlling and monitoring and managing those jobs remotely. The log, and let's see what we got back here. So we have a database that did not meet that differential schedule. Okay, so this instant restore database, something I tested on earlier, did not meet that schedule. So it says the operation did not occur at 4 o'clock like it was supposed to. I can then check the boxes, say run selected operation. I'm not sure if that database exists. We'll see. Yeah, let's see what the result was. Yeah, so I deleted that just a few minutes ago. So unfortunately, it hadn't picked that up yet. Nevertheless, um, I got to see the result as why that failed. But it's important to understand that, right? So we got that red X here because it noticed that one of the servers where I said all user databases didn't have a differential for this particular DB. Now, because of that, it's going to highlight for me this DB needs to be backed up. It gives me that easy check mark. Let me see if I can't break another one of these policies, and you'll see what I'm talking about. So if I come in here and I say edit policy for log, let's see what the schedule is. So the schedule for this guy is every 2 hours. Maybe we change our minds and say, hey, that needs to run every 15. Yeah, we'll say 15 minutes. All right, so this is important in that this is going to do a couple things for us. First off, I'm going to set notifications around that if I need to. When I hit finish, it's going to go update all those different log jobs on those remote servers to a new 15-minute schedule. Now let's see. Unfortunately, it's not going to break because these all just ran at 4 o'clock. But the point is, if it noticed that these logs didn't back up within the last 15 minutes, this policy is going to turn red and then tell me which files I need to go back up. And frankly, can do that for me automatically if I need to. Within the next 15 minutes, everything will be fixed. So backup policies aren't terribly complicated. It's actually a really easy way of controlling and managing backup and recovery. Policy recovery is done, there's 2 ways to do it, I guess. You have a log shipping model, which is basically just scheduling a full and a log in the same policy for restore. And then you have what we call restore policies that are focused purely on full backup. So the way those work is the first step is really naming it, right? And then it's going to want to know which SQL Server database are we concerned about here. So on my laptop, I have a database called Financial Records. It's a member of the policy full and diff, right? So it's going to be monitoring that full and diff policy to identify the most recent full backup. You can change accounts, you can set up network resiliency. I don't really need to do that in my environment. And then it will want to know, all right, well, where are we going to restore this file? What do you want to call it when it's restored? Where do you want the data and log files to be, or data files and log to be? And then down below, what's the schedule? So I back up the full at midnight. I tell the restore to happen at 12:10. I don't really have to do that. I could just say midnight, and it will kick off as soon as the file is available. The point being that if you need to automate restores, we can do that as well. The only caveat to that is it needs to be a member of a policy so we can identify the most recent file to restore. So scheduling is really pretty simple. Let's get those backups done on a typical way. And then if there's any problems with that stuff, we can notify you, say, hey, there's an issue. Where it really starts to get interesting is recovery. So restoring the database, I'll show you just kind of a traditional point-in-time recovery. So if I wanted to restore a DB like compliance, right? So let's go ahead and restore this database. As you can see, what I did was I identified the server, I identified the database, right-click, restore. That'll initiate a wizard. In this case, where do you want to restore to? So we have a whole set of SQL servers that we can work from. Maybe we'll move it to a new box. So we'll say from dev 1 is where the original was. Let's restore to dev 2. You can disconnect users before the restore takes place. That's very beneficial if you're overriding an existing database. Then we'll start getting into the files, right? So the original location of this database was dev 1, so it's looking at my SQL Safe repository database and looking at all the different databases we've backed up. Compliance is checked because that's the one we're looking to restore. So I don't really have to think about this page much as long as I have my repository intact. If for whatever reason I lost the repository, I could always start browsing file systems, right? And picking the individual files that we want to restore. But again, we have and you can browse Amazon, you can browse Tivoli, you can browse remote systems and local systems. Basically, you can put a UNC path and look anywhere you want. But we have the repository, so we don't need to worry about it. Let's go ahead and use it. Now, as you can see here, we have different colors. So this is that timeline I mentioned earlier. That repository knows where all the backup files are. An orange bar is a differential. A blue bar, that's a T-log. a pink bar is a full, and then obviously differential more T-log. So if I wanted to restore it, what is that? 340 in 2 seconds? No, let's go to 340 in 4 seconds. Right, so this is the point in time I want to restore to. It's going to go through here and pick the appropriate files. We can then determine what we want to call it. So it's checking to make sure the agents have access to these files where they're written, so that they can be restored. And we'll give it a few more seconds. So it's pending. It's looking for those logs. Good deal. So it found everything. Now it wants to know what we want to restore this database as. I generally would call this demo or something like that. So down the road I know, hey, this is not really important. We can delete it. Where's the file path going to be? And it, by the way, this defaults to where the file location originated. So this can get you in trouble if you're, if this target location doesn't exist on the new server, you may need to edit that. Force replace, right? So if you're going to override an existing database, you may need to check that as well. And then what state do you want to leave it in? Let's leave it in full. In this case, we'll do a normal recovery, set up notifications. Again, just like backup, you can script. So this would be the T-SQL script, or actually command line script to do the restore. If you notice, there is a password in here, right, for the Windows password of how to get access to that file. And then there's also a stop at time here. So this stop at time is where we're going to roll the T-logs back to, so that we're at that exact point in time. You could also have obviously done this through T-SQL, assuming that you had the extensor procedures deployed, or what we're going to do is hit the restore button, right? So it's going to queue things up. So it's doing the full restore right now. It's queued up the T-log. So I didn't have to do the math. It figured everything out. This is actually pretty simple, just 2 files, but if it was 100 files, that could get a lot more complicated, and you don't have to think about it. It can do it for you. So that's more of a traditional restore. All right, so now what we're going to do is we're going to talk about instant restore. And instant restore is very beneficial for people who have large databases. If you have a big 2, 3, 15 terabyte database that takes hours to restore and you need it back instantly, that's where instant restore really comes into play. So what's actually going to happen here, we'll go ahead and we'll do something like the dashboard repository. So one thing I didn't point out, if you just want to restore a file, right, or a backup, I can just right click on it and say restore, right? So it knows the file I selected, and it's going to walk through the wizard, already have everything predefined. So it makes it pretty simple. Now in this case, we want to rename it IR for instant restore. We'll put demo in here just so I know I can delete it later. And instead of doing a typical restore, we'll do instant. The really nice thing about instant restore is, again, you don't have to wait to get access to the data. What's going to happen here, if we come up to the top, and this happened pretty quick. Unfortunately, it happened quicker than I thought it would have. So what happens is it's 2 steps. So the first step is the creation of the new database, right? So we'll create empty data files and an empty log file for this DB. And then the next step is hydration. And what hydration is basically doing is taking the pages out of the backup set and plugging them into this new database that's living in SQL Server. So what's really happening is a prioritized restore. So if I'm doing a select against a table and that data hasn't been written to this new data file yet, we grab it from the middle of the backup set using those maps that we talked about earlier, and we restore it first. So as hydration gets further and further along the process, the faster these hydrating databases are going to be. What I mean by that is a database during the instant restore hydration phase will probably run about 20% slower than a traditional database would. But as soon as hydration's finished, it is a traditional database, so that speed's going to be just like it used to be. And again, as the data is hydrated in there, if all the lookup tables and stuff that you've already used is already restored, then it's going to get faster and faster and faster. Normally in those really big databases, a lot of it's older data that's not used day in and day out, or minute by minute or second by second. So instant restore on really big databases actually does perform fairly well. But the big benefit here is I get to tell my end user, hey, it's going to be slow for the next hour, rather than having to tell them you can't do anything for an hour. So using instant restore gives you access pretty much immediately to the data. And again, that's a big benefit over anybody else out there in the marketplace. So the last thing I really wanted to talk about before we end the call is the web console. So there's a lot of flexibility within the web console that really adds to the SQL Safe application. So when I talk about the web console, we have what's called the IDERA dashboard, and SQL Safe is one of the products that can live within the IDERA dashboard. That's what we're looking at here. And in the web console, for example, if there's data, there's a lot of filters that I can leverage. So I want to look at the statuses of something. Maybe I want to look at errors. If we had errors, so there's a few errors in the past, I can go ahead and export this out to PDF, Excel, XML. So this is one way that we can essentially report, I guess, off of the data that we've collected. But there's also some real features in here that aren't available in the desktop client. For example, object level recovery. So if I want to do an OLR restore, first off, native encrypted and compressed 2014 or higher is not supported for OLR. That's not really a big problem. Obviously, we're using our own backup strategies here. So SQL Safe 2017 backups are supported encrypted compressed. So that's talking about a native BAK file, which we would support for previous versions of SQL Server, or non-encrypted and compressed for newer versions. But OLR, again, part of the reason why people need OLR is, let's say we have a giant database and we need just a small table out of it. Let's not restore the entire database to get that table out. Let's just pick the one we need. So I can identify an instance where we want to restore that, and then obviously we need to find data to restore. So let's look at the healthcare database, and then which backup do we want to leverage? We'll take this full right here. So what we're doing on Dev 1 is we're going to create a subset of that data, right? So we're not going to restore the entire healthcare database. We're going to create a brand new DB called healthcare OLR. And then maybe I just want, this stored proc. And I want, I don't know, a table, right? So we want the prescriptions table. Right, so I'm not going to restore the entire thing. I'm only going to restore part of it. So one of the big things to understand, I guess, is that healthcare, I'm not overriding that store proc in that table into my production healthcare database. Let's see. So what I did was I created a new DB called healthcare OLR, and if we go look at the tables, here's prescriptions. If I go look at stored procs, here's my most expensive products, right? So I didn't do a full restore, it was just a few objects. But again, the big takeaway here is obviously object level, but also that you're going to restore into a newly created database. We don't overwrite your existing data. So something to keep in mind, I would have to script this table out, or I'd have to script this store procedure out and then bring it into production. But we think that's more of a conservative approach. We think that's a better way to do it than overriding production data with tables that might not match up perfectly. So that's one of the options that you have in the web client. Another one is virtual database. And what virtual database really is all about is attaching backup files to SQL Server without having to go through the restore process at all. Now, the big difference between a virtual database and an instant restore is that the end result of an instant restore is a working, functioning, fully normalized database. Virtual database, on the other hand, is never really intended to be a normal database. Really what I'm using virtual database for is to skip the requirement for disk space and skip the requirement for time to get access to information around an older backup file, right? So I'm tricking the SQL Server into believing this backup file is the actual database. And it's pretty simple. Basically, you would walk through, you'd say attach. So first off, you would select the instance. Maybe we're going to create one on Dev 2. We're going to browse out to Dev 2. It'll look through the file system. We'll grab a backup. All right, and that could be UNC path. I just happen to have a backup sitting out there. So you could put in any path you want to this file. Now, and then what do you want to call it? So we'll call it DM_VDB. So basically on Dev 2, we're tricking it into believing that this full backup is a database called DMVDB. So when I say create here, if we go out to Dev 2, right? And we look at the databases view right here. So here's that DB. So as far as SQL Server is concerned, these are real databases. So if I want to look at disk drives, right? I'm selecting this data. The The information that I'm getting back, though, is coming from within that backup file. So again, one of the big benefits of this is that, first off, let me go show you, is that you didn't have to find any space for it. If we go in and we look at the, come on, Dev2, logging in. Okay, so we didn't have to go find the space for this, and you can see it literally in here. So there's a folder that we create called backup. In here, you'll see the file. So this looks like it's a 25 some odd gig database. But the reality is, if you look at this on tape or on disk, so it says 25 gigs was the size of the DB, but it's only taking up 7 megabytes worth of space. So this could be 30 terabytes, and it would still only be probably 150, 200 megs worth of space. So I didn't have to go find the space, and as you saw, I didn't have to wait for that 25 gigs to be restored because, again, I'm just tricking that SQL Server into believing that this is a real DB. You can insert, update, delete. You can do anything you want with the VDB, but just be aware that we're never going to modify the backup file. So any changes that you actually make to a virtual database are going to be in these sparse files. One thing that you could do if you did make a bunch of changes to a VDB and you wanted to preserve them, you can back up virtual databases, and then when you restore them, they're real databases again. So obviously there's more to the product that we didn't have time to get into today, but really I just wanted you guys to get a really deeper insight into how this product works. Obviously we have trials available online. If you'd like to go out to the IDERA website, you have under the products list, you'll see SQL Safe right here. So you can just go in, say buy. You can buy now, I guess, but there's also a start for free, and that will give you a 14-day trial up to 15 SQL servers. Once you download, you'll be contacted by one of our account managers, and they can help you with licensing and that sort of thing. So I appreciate everybody's time today. Hope you enjoyed it. Thank you.